All right, so looking this over, it's what's congruent with my. Well, my is here. And we know that yp or yp is a perpendicular bisector of EM. So that means this side congruent to this side. So my is congruent to EY, right? And we can do that all the way around the triangle because all of these lines are perpendicular bisectors, right? So ER congruent to RK, NK congruent to MN. What we cannot say is EY congruent to ER. No, no, no. We cannot say that KR congruent to NK. Although they look congruent, they are not well, we don't know if they're congruent. Right? All we can say for certain is that MN congruent to NK. So that's going to help you answer all of these questions here, but now we're at question number 4, KP. So KP is not drawn on the figure, but it's the point from the circumcenter to the vertex K. Now, we know that the circumcenter is equidistant to all of the vertices. So that means PM, which is also not drawn on the figure, is congruent to PK. And those two are also congruent to EP. Right? EP is also from the circumcenter to a vertex of the triangle. So question 4 has 2 answers. Right? It's like EP congruent to MP, and also MP is congruent to PK. Okay, so that's that. And now we're going to move on to the angle bisectors. Okay, so we have 2 theorems here. We got the angle bisector theorem, and what that one says, if I go ahead and erase all of this here, is that, well, first of all, we need to know what an angle bisector is. And it is a line that bisects an angle into 2 equal angles, right? Cuts an angle in half. So if we're looking at this triangle here, we could say that this line there is an angle bisector if this angle is congruent with that angle, right? So what is this angle bisector doing? It's cutting this angle ABC into 2 congruent angles, which are ABD and DBC. Okay. So if that's true, then we know that it is equidistant from the sides of the angle. What does that mean? That means that this line here, any point on this angle bisector, is equidistant to the sides of the angle, right? So BC and AB. So how do we set that up? Well, it's going to look like this. This is going to be a right angle, and this here is going to be a right angle as well, right? So this is our setup here, where we have these 2 lines that are coming from the angle bisector, and they form a right angle with the sides of the angle. Then we could say that this line segment is congruent to that line segment. Okay, now what does the converse of angle bisector theorem say? It says that if we have a line that looks like that, but we don't know if it's an angle bisector, and we have this line here which forms a right angle with the side of the angle, and we have this line here which forms a right angle with the side of the angle, and we're given that these 2 line segments are congruent, then we can say for certain that this line here is an angle bisector and that this angle is congruent to that angle. Okay, so it's just basically the opposite of the angle bisector theorem. So that's going to help us, because so here we have our example. We have MR is the angle bisector of angle NMP. So we're given its angle bisector. MR is angle bisector of NMP. It doesn't look like it. Angle 1 looks like it's smaller than angle 2, but we're given that that's true. So since we're given that that's true, then we know for certain that MR bisects the angle MMP. So angle 1 congruent to angle 2. If angle 1 is this expression and angle 2 is this expression, we simply need to say measure angle 1 equals to measure angle 2. Or 5x plus 8 is equal to 8x minus 6. And we solve for x. We get x is equal to 8. Okay, so that's going to help you with these problems right over here. Right? See, look, number 1, we are given that AE is the distance from the side of the angle to this line here. And we're also given that EC is the distance from the side of the angle to BE, and they both form a right angle with the side of the angle. Right? So since that's true and we're given that AE is congruent to EC, well, then the converse of angle bisector theorem kicks in, right? And then we could say for certain that BE is the angle bisector of ABC. And they're looking for angle ABE, right? This one here. So I'll go ahead and let you work on these problems, and then we'll go over the answers in the next video.